Hello and welcome to the first week of content here. This first week we're just there's gonna be an introduction to the class and an introduction assignment to the MyLab, and that's why your homework assignment is kind of long this week. The introduction isn't bad though, it just basically alerts you to the features of MyLab. And then basically the real focus of this week is gonna be on chapters 2.1 and 2.2 here. So that's all basically related to the Cartesian coordinate system, and then we're going to talk about solutions to linear equations, slope-intercept form of a linear equation, graphing linear equations, finding the slope of a line if you're given 2 points that lie on that line, finding the x-intercepts and y-intercepts of linear equations again, and then finally we're going to wrap it up with finding the x and y-intercepts of quadratic equations here. Alright. So first thing, of course, we might as well talk about here is the Cartesian coordinate system here. And the Cartesian coordinate system is just simply the coordinate system you guys are all used to. Usually it has the x-axis and the y-axis. Sometimes they can be like cost and profit, or you can call them different variables, but for the most part it's just x and y-axis. And of course, there's both positive and negative values on the x-axis and positive and negative values on the y-axis. So then an xy pair can describe every single point anywhere on this plane or this Cartesian coordinate system. So just an example of one point we have right there is -3, 2. So again, that's an xy point. So x coordinate, the -3, that means you went backwards, 1, 2, 3 on the x-axis. And then the 2, which is the y-coordinate, means you went up 1, 2 on the y-axis, right? So just to give you a little bit more of an example, well, if we move that point over to the right here, well, we go from the negative x-axis over here to the positive x-axis, and we'll just leave it there for fun. So now, let's see, on the x-axis, we're at a positive just over 1, and on the y-axis, we're just below a positive 2. One last thing on that is the quadrants. Now, you notice this Cartesian coordinate system is separated into 4 different quadrants. This guy right here is the first quadrant. This one's the second, third, fourth. So just counterclockwise with the positive x and y being the first quadrant. Alright, next thing I want to talk about here are solutions to linear equations. So actually to talk about this, I'm going to check out a problem for your homework assignment here. Alright, so right here we're asked, determine whether the point 9, 5, so again that's the x coordinate of 9, y coordinate of 5, is a solution to this equation right here where 16x minus y plus 15 equals 0. So the first thing I want to mention is, well, first off, it's specified solution to linear equation. We know this is a linear equation because the variables are just to the first power. There's no like squared or cubed variable. Now, next thing is, what is a solution? Now, a solution to any equation is a set of points, or in this case, since this equation has x's and y's, we need an xy point that where if we plugged it in, we will get a true statement. So let me show you a little example here. Let me start off with my equation right here. I'm just going to rewrite it. It is 16x minus y plus 15 equals 0. So once again, a solution to this equation is an xy pair where if I plug those in, I will get a true statement. So let me show you what I mean here, or let's see what happens when we plug in our xy pair. So I rewrite it now and I put 16. But now instead of having an x right there, I want to replace it with the x value of interest, which is a 9. And now bring down the minus, but now instead of putting in a y, I want to put in our y value of 5. Then I'm going to bring down the plus 15 equals 0. And now let's simplify this expression right here. Let's see, 16 times 9 is 144. Minus 5 plus 15 is equal to 0, right? Now let's simplify that a little bit further. Let's see, 144 minus 5 plus 15, that would be 154. So we'd have 154 is equal to 0. Now, is 154 equal to 0? No, it is not true. So because we got an untrue statement or a false statement right here, we know that that point right there does not lie on this line. So is that a solution? I would say no. Oh, great job. Alright, next up what we're going to start talking about is slope-intercept form now of those linear equations. So first off, what makes an equation a linear equation again is just that the variables are to the first power. Now the slope-intercept form is just a special way of writing a linear equation with m right there, or the m representing the slope of the line, and the b right there representing the y-intercept of the line. And in just a moment here, I'm going to talk a little bit more about basically, well, what the slope and what the y-intercept means. But before we get quite to that, let's look at a few examples from the homework where all you really need to know is just basically how the equation is set up. So let's see what we have here. Find the equation of a line with the given y-intercept and slope m. So here, let's see, I guess our y-intercept must be 19. And our slope must be 4 here. And we want to write the equation right there. Alright, so once again, slope-intercept form is that y equals mx plus b form, where m is going to be the slope, and b is that y-intercept. Alright, so of course, we're just going to start off with y equals. Now, instead of writing m in, we want to put in our particular value of m right there, which is 4. So it's just going to be 4, and then we put in the x from the equation. And then now let's see. Our y-intercept in this case is given as 19. So since that's a positive value, we want to write in plus 19. So right there we have it, our slope of 4 and our y-intercept of 19 written in, and see what we got. Oh, well done. Alright, we'll check out another one of those real quick. So here, of course, our slope is negative 2.7, and our y-intercept is given as 3.4. So we just start off again, of course, y equals. Now our slope is negative, so that's going to be a negative 2.7x. Now again, our y-intercept is positive, so it's going to be plus 3.4. And we have it right there. Alright, this one, same deal, just you select the correct form. So let's see, m is negative 1/2, or the slope's negative 1/2. So let's see, it could be that one has a slope of negative 1/2. Well, that one's not in slope-intercept form. That one's not in slope-intercept form. That one is, but has a slope of 3, so it's got to be that one. But of course, the y-intercept here is 3, and we're told the y-intercept there is 3. So everything matches up. Now, this next question, a little bit different here. We're asked, find the slope m and the y-intercept of the equation b, the y-intercept b of the line whose equation is given as 5x minus y is equal to 2. Now, that is a linear equation because, of course, we just have x to the first power, y to the first power. But now the thing is, that is not in slope-intercept form. That actually happens to be in standard form, not really important, usually we use slope-intercept form. But now, the whole beauty of slope-intercept form is that basically, just from looking at it, we can identify the slope m and the y-intercept b, right? Which is what they're asking us for in this problem. So it kind of makes sense then, if we could take this equation right here and put it in the slope-intercept form, of course we could answer what they're asking us for. So how you do that is, well, I always start off with writing my original equation, 5x minus y equals 2. Now, to put it in slope-intercept form is, of course, to put it in that form. But I think the best way of thinking of it is just get y by itself on the left-hand side. Alright, so if I want to get y by itself right here on the left-hand side, well, let's see. Since that's a negative y, I need to divide by -1. And since we also have a 5x right there, I need to subtract 5x from each side. Of course, since I'm solving basically for y, I'd want to do reverse order of operations. So the first thing I'd want to do is subtract 5x from each side. And rewrite my equation here. So let's see, it cancels off right here. I'm left with negative y, bring down the equal sign, and then we have 5x plus 2. Now, I just want to mention I could have wrote that as 2 minus 5x rather than negative 5x plus 2, but I just wrote the x term first and then the constant because that is slope-intercept form with the x term first and the constant second, but you could rearrange it later. Alright, now of course, lastly, I want it solved for y, not negative y, so to get rid of the negative, you just want to divide each side by negative 1. And of course here the whole point was that negative cancels off and you're left with y is equal to. Now let's see, negative 5 divided by negative 1 is going to be a positive 5x. And 2 divided by negative 1, that's going to be a negative 2. So that is our equation right there. Now let's see, find the slope m and the y-intercept b of the line whose equation is given. So of course, right there's our slope. And here is our y-intercept. And let's put in those values just to make sure I'm not lying to you. So slope, put in a 5 right here. Check the answer. Alright, nice work. And the y-intercept, we came up with a negative 2 here. And check the answer. Alright, fantastic. Alright, next thing I'd like to discuss a little bit is graphing. And mainly graphing based on slope-intercept form of a linear equation. Alright, so once again, this is just going to be based on our y-intercept b and our slope m of our particular linear equation. Now, what you always do is you always start off by identifying the y-intercept or the b. So to do that, we'll look at the example we looked at last. That last example, we ended up with the equation y equals 5x minus 2. So now in this situation, again, we want to identify our y-intercept first. In this case, it's going to be negative 2. So that is where it crosses the y-axis. So of course, this is the y-axis, that's the x-axis, and 0's right there, negative is going to be down here. So that's the point right there. X is 0, y is going to be negative 2. Now, from the y-intercept, what you do is you use the slope to basically find another point. So now the idea here is that the slope is, you guys have probably heard this before, the rise over the run. So that's basically how much the line goes either up or down over how much the line goes over to the right. Alright, so let's look at our slope again in this equation right here. So of course, our slope m is equal to 5 in this situation, right? Now, a lot of times when people start graphing, they like to think about it as the slope is a fraction, so that way you can think of it as rise over run. So of course, anything divided by 1 is still itself, right? 5 divided by 1 is still 5. I just wanted to make it a fraction. So of course, again, that is equal to our rise over run. So now, what I do is I start off at my y-intercept and I use that slope to find one more point. So first I look at the rise, which is going to be a 5. Well, a positive 5, right? So that means I'm going to go up 5 units. So up 1, 2, 3, 4, 5 units, but I'm not quite done. I still have to take into consideration this run, which is how far it goes over to the right. And now in this case, my run is 1, so I'm going to go to the right, 1 unit right there. And let's see, that new point right there, well, my rise was 5, so I went from a negative 2 to a positive 3. That'd be my y-coordinate. And then my run was 1, so of course I started off as an x-coordinate of 0, and I ended up at an x-coordinate of 1, so that would be the point 1, 3. Alright, so that's all the time I have to make videos here this week. So what I'm going to do is, since I didn't quite get to finding the slope of the line given 2 points, or x and y intercepts of linear quadratic equations, after this video, I'll have links to other videos of somebody else going through those topics for you. Hope you guys enjoy.